Who is also joining us online. Ian Padilla, are you there?
Hello, I'm here.
Hi, Ian. Ian is from WeGaw, and the floor is yours, Ian.
Thanks. So yeah, my name is John Padilla. I'm CEO at WeGaw, and what we're doing at WeGaw basically is exploring remote sensing satellite data analytics with machine learning, specifically to help the energy actors, energy traders and producers to better trade and produce energy in a more optimized way. If you can go to the next slide. So basically, we are moving into this new world, which is completely clean, or we want to be completely clean. And this is coming with a challenge, right? In the past, it was really easy to predict future energy production from coal, from oil, from different sources. But right now, it's more and more complex because of these renewable energies, right? It's really difficult to know how much wind, sun, or water there is going to be tomorrow in order to produce energy. This is creating lots of uncertainties on the market. Energy price is reaching record in terms of volatility, and it's spiking as well in terms of load, which is creating lots of unprecedented imbalances for our electric utilities, traders, and grid operators. These for WeGaw represent an opportunity that we want to capitalize the following way. Next. So our weapon of choice in order to help all these actors better predict future energy production from renewable energies, it's the combination of remote sensing satellite data with machine learning. Next. So basically what we do is that we combine several different satellites from the European Space Agency and NASA with primarily radar and optical sensors, in which we are going to apply our proprietary deep learning models. And what we're going to have as an outcome is environmental variables that are the key in order to understand future energy forecast. And in this case, the environmental variables that we're considering are primarily water and snow for hydropower. Next. So the core technology of WeGaw is how we're using machine learning in order to extract these key environmental assets. So what you're able to see here is on the left, you see the download radar data set from a satellite that, using our deep learning model, combining with 250 million data point samples, we're going to produce the image that you see on the right, which is a snow depth product from WeGaw, which has 93% accuracy, which is something unpredicted till now. Next. So obviously these data, which is water and snow data with such accuracy that we can provide to our partners and to our clients, it's being used to optimize hydropower production. Right? In this case, what we are providing is usually two use cases that this data is being used for. The first one is to optimize short-term discharge. So what we can do is that detect as soon as snow is becoming wet, as soon as snow is starting to collapse, we can inform our clients that this is happening, so that they effectively swap their operations on the dam so that they can capitalize on this edge information. This would be for short term, so this usually we can help our clients understand this with 5 to 10 days in advance. But what we're doing as well is seasonal forecast as well, primarily through our partners, which they are going to be ingesting our snow depth, snow water equivalent data that we produce directly from our satellites, in order to understand what is the future water availability and therefore the future energy production, to be able to ensure a proper trading strategy of these water, which means how we're going to set up our power futures, how much energy we're going to leave for the spot market, how we're going to protect ourselves from imbalance, helping them increase up to 10% the energy production, and helping them improve 5% the pricing of that energy. Next. So we have a really simple business model, which goes per power plant or per area that wants to be monitored. That ranges from usually $5,000 to $20,000 to be monitored. Next. The markets that we are trying to capture is obviously the hydropower market to begin with. We're focusing in the 20,000+ power plants that are around Europe. Basically, if we would use our data analytics, we will help these electric utilities into optimizing this energy production through this product. We will help them generate an additional 26 terawatts of energy without zero investment in new infrastructure, just by better usage of WeGaw data. This market opportunity for WeGaw will represent around $100 million in estimated annual opportunity. Next. So this is the team behind all these, myself and Daria, which by the way is on site, so don't hesitate in bumping into her. She's the expert in all the technical aspects of the company. So we're both leading WeGaw. Daria with me, she's an expert in special technologies. She comes from the UN, and she has been working for the Portuguese government, doing primarily machine learning and geospatial technologies. Myself, I come from CERN, which is around the block. I have a background in software engineering, and I have been part of Hewlett-Packard as a business consultant as well. Together with us, we have Gonzalo, Tom, and Hugo, which are our solution architect, Earth observation specialist, and environmental science professionals that are helping us primarily in putting all this data together, building the machine learning algorithms, building the supply chain from satellite to the final data set, and connecting all these with our partners and clients. Next.
You're quite over your time.
Sorry, well, I'm here are a few references of different projects that we have been working on, and the different proposals that we're working on at the moment. Next. And the final call for our collaboration is that we're raising £1 million Swiss francs, which is already at 60% confirmed, and that we're obviously looking for partners, collaborators that want to test this data in their watersheds and in their hydropower plants. Thank you so much.
Thanks, Jan. Sorry to push you, but we've got a tight schedule, so thanks for that. No problem.